All right, good morning, everyone. Thank you for joining us on the last CBT monthly Azure webinar. And yes, Adnan is back with us again today. And today we're going to be looking at serverless computing. So to be specific, we're going to be talking functions and logic apps today. So Adnan, if you're ready, the floor is yours, Adnan.
Thank you very much, and welcome everybody. And once again, Kazim, thanks for having me again. My name is Adnan Hendricks. You guys can follow me online on my social media channels just by looking up at Micro Specialist. And like Kazim said, today we're looking at serverless computing, specifically a part of serverless computing within Azure, and that's functions and Logic Apps. Logic Apps is also looked at as an integration thing. But before we really get started with the technical stuff, we really need to look at how far we've come with IT. For example, one of the main reasons we have computers is really to run programs. So back in the day, you had to have a specific type of operating system. You install your application, and that's pretty much what runs. So looking at now, we're living in a cloud cloud environment. How are you making your apps available, your applications available? So a lot of people are still creating virtual machines and hosting their applications. But with cloud native applications and with the new capabilities that Microsoft and other cloud providers provide, we can actually abstract the application from the underlying platform. So this slide is really the questions that you need to ask yourself, like, where are you now? If you're not working with cloud at the moment, then whatever you're working on is quite outdated already. And also, how are you specifically hosting applications, doing your work, doing certain sort of automation within your infrastructure? Where you're doing it, is that still relevant? And the big picture is always ask yourself your why. Why are you doing what you do? Like for me, I hope that when I'm 100, I still get to do tech stuff because I love doing it, same as Kazim probably. But going back to the tech, so we're within Azure Serverless Platform, some of the components. What's
Did
that?
I hear you say 100?
Well, if I make it, I still want to be busy and working. Yeah. Every year I get is a plus, so
Okay.
I take what I get. So I just want to go back to the platform components that I'll be discussing today. Azure Event Grid, and that's really just the service that enables all my backend subscribers to get a specific event. And Logic Apps and Functions are really just the serverless components that take that event, whatever's happened, and act on it. Okay? And Functions, I'll go more deeper into these things. Functions basically just the code that will go and entail on the events that's been specified. So looking at cloud, with Microsoft being, we talk about economies of scale, that buy more, it makes it cheaper and easier for us. So the platform that they provide allows us to do quite a lot of things, so we can still create virtual machines, and we have this new serverless platform. And later on, I'll show you guys really just how cheap that can be. So within a cloud environment, we always talk of the kind of services that a cloud provider provides, or a public cloud provides for us. So infrastructure as a service, we can still have virtual machines, networking, but then there's the PaaS services, so platform as a service services. For example, things like Azure SQL, we just need to do a database, and that's hosted. So between PaaS and software as a service, things like 365, the hosted applications, you can see that we've moved quite far. And if we go talk about serverless, it's really where it's like a PaaS service, but we don't really have to worry about the underlying infrastructure, much like specific PaaS services. If you look at a web app, for example, where the platform is still hosted and controlled underlying infrastructure with Microsoft, and we pay for that, what we take off. So the shared responsibility, just looking at where you can see how far your responsibility is and the less work you can do. So serverless is kind of like a blend of PaaS service. And when moving towards serverless, the lower cost you will be. For example, we have on-premises where we basically manage everything, so there's a big, large cost involved. Infrastructure as a service, you're still doing a lot more than PaaS and serverless, so there's more cost. PaaS, you're only worrying about your things like app or your database, so it's even less. And when we move towards pure serverless, which is just slightly further than what PaaS offers, it's even cheaper, you know, so we pay even per second, and we still have that large scale. So in underlying or hosting an application, we have the app service, and things like functions are, you know, they kind of fall under that fully managed platform of app service as well. So it's where you can either lift and shift your application code, you can go run it as a container, you can have underlying infrastructure, and you know, it doesn't really matter which kind of language that you're writing your application in. You know, a lot of things are supported for your code, and you can deploy that easily through Azure or DevOps, you know, utilizing Azure DevOps, and just have the integration much easier. So when looking at the overall Azure architecture picture, you know, under the Azure Resource Manager model, you could say that some of the workloads, like the compute, networking, storage, you know, functions is really a form of compute, you know, just a different platform. I quite often get asked, you know, like, what's the next big thing? And then you generally have two camps. So on the one side, we want to, you know, move further away from the infrastructure, where a cloud provider is handling that, and just focus on our code. For example, serverless computing. And then in the other camp, you also have people that are moving more towards containerization. And if you have done something with Azure Kubernetes Services, or AKS in short, where you can have your entire application written in AKS or Kubernetes. And I'm sure that in one of the following sessions, we'll be doing one on AKS, I believe, Kazim. So it's just one of the platforms where we can host our application. Because we've always dealt with infrastructure as a service or on-premises where we have too much management. So we still need to find out how many servers we need, you know, sizing the service, because what happens if our app gets too busy? How are we going to scale that? How do we upgrade our application when we need to deploy code, things like monitoring, and there's always the patching, the backups, which packages need to be on there. So the evolution of the application platform as we move from Azure Infrastructure as a Service, PaaS to serverless, you know, we really think about cloud native applications. So cloud native applications are serverless. You know, they have all of these properties. So we have a total abstraction of the underlying server infrastructure, instant scale, everything is pay per use. And I think in my next slide, I'll show you guys one of the you know, how cheap it can be, and you have a large flexibility when it comes to your development process, because even though it is something innately cloud, there's a lot of the tooling that you can still go and develop your application, for example, on your local computer, and still have the exact same function runtime available locally as you would in Azure Cloud. And with all these things, you know, it will still be secure and compliant with all your compliancy levels, enterprise level scale, so up to enormous scale levels, minute scaling controls, with a lot of monitoring controls for functioning of your application. And like I said, even if you have a hybrid environment, you have a lot of these capabilities for both hybrid and multi-cloud. So just to show you quickly, and this is something that you can go look at it yourself in the Azure calculator, cost calculator. By selecting a function, you'll be able to see based on the executions of that function, which is really just the code. And you can see that the first million executions of your function is basically free. So in one of my demos that I have set up that utilize functions, it's really, you know, going in effect the minute somebody accesses my application. So it's not something like a virtual machine that's always running, that's always incurring costs. Only when my function runs, that's when my costs incur. So every time it's executed, etc. So that does impact the pricing quite a lot. I mean, for example, just think about having an application constantly running where maybe it only needs to run once in a while. And remember, in the cloud life, we're looking at event-driven applications. So something happens, and then my function needs to act. Same thing is could be user-driven, one of those things. So there's quite a lot of active users, a lot of function apps in existence, and billions of daily function executions happening on Azure daily. So just going back to the different serverless platform components. So starting off with event grids. Event grid is really just the service that handles all the events that can trigger your function or your logic app. And then your logic app is a orchestration process in the form of a workflow that can enable functions or certain programmatic capabilities based on that trigger. Functions is basically just executing your code that can be in a number of different code languages on the events that you specify, and the code obviously provides a result. And all these platforms can integrate and in effect be events from the underlying options like database storage. Utilizing Azure AD security, we can utilize things like Azure Key Vault for secrets that might be needed to be accessed within functions or logic apps, etc. And then at the same time, interact with IoT devices, have global scale analytics and intelligence enacted on it. So just get started with Event Grid quickly, and passing through that is all about, or cloud native computing is all about events. An event happens, and whatever that event is, you want to have an outcome. So sometimes events can be too consuming, overwhelming. If you look at the number of tweets that happen every minute, or the Instagram posts or Facebook, and we look at things, especially when it's social media, how many billions of people are on the planet, Everybody's got a mobile device. Everybody's busy, so there's quite a lot of events happening. Same thing within businesses. How many transactions? You know, you got a web application, you got customers buying from all over the world on the same application, all those transactions being written and made. So one of the services that can actually handle that kind of load is Azure Event Grid. And that's one of the reasons why I'm mentioning this, is because it's kind of the backbone of event-driven computing within Azure. Okay, so it contains fully managed event routing with near real-time event delivery, you know, at cloud scale, and it has broad coverage not only within Azure but also beyond Azure, some other third-party services. And the benefits is that, you know, the hard work has kind of been done for you, so you focus on your application innovation, and you basically just pay per event if you want to be setting it up as a service yourself. And you know, having all the tie-ins to other cloud services and other services, that reliability and performance for your applications, and just making more scenarios and things available. So it's your one-stop spot for all your events. Similar services, things like event hubs and service bus also have similar functionality. Event hubs is more for point-in-time data, so it can pull in data, and especially for big data streams from different services. And then service bus is really just setting up queues or routing between application, transactional applications. Event grid is a push, and it guarantees delivery, and depending on the type of scenario or event that happens, it can pass through that business logic. So some of the scenarios that have capabilities for event grid is things specifically for serverless applications, because all serverless applications are triggered by something happening. So that event is ideally handled through the event grid. And then operations automation. You know, you want to speed up automation or enforce Azure automation or policy enforcement within your infrastructure. Azure Event Grid can just send the trigger off to different underlying services, and that can be effected. Application integration, another big step. And here we look at different topics depending on one event that's happened. So your Azure Event Grid, you have all these different event publishers depending on the type of service. For example, we have specific Azure services in this on the left-hand side with event publishers that picked up through the event grid, and the event handlers. And the event handler is really just the process that is actionable when that event occurs. So you have your functions, your logic apps, you can have some sort of Azure automation as well, and things like webhooks. So basically all your events, and you can subscribe to an event and then route the event to a specific subscriber type, a handler for that case. So this was just quickly talking about Azure Event Grid, which is really just the underlying service that handles the event triggers. So near real time, massive scale out, and large numbers for reliability. So some of the concepts: the event that happened, the publisher, the topic where you could send the event, the subscribers, and the handlers. So when looking specifically at one of the event handlers, functions, a function is basically your code, your piece of code that gets triggered by an event. So you have triggers from different sources. It could be something that's written to blob storage, for example, or within a database, or coming from an event hub data stream, or HTTP webhooks, or something happens on a HTML web page, or coming in through a service bus, or happening on a timer. So you have all these different triggers, and then the binding is really just what kind of data is really affected. So the binding is a file is written to the blob storage, or a table is updated within Cosmos DB, and a number of these things. And one of the scenarios, you can have a function running every 15 minutes that might go look at a data table, look at invalid data, and just provide clean information to make sure that you're working with accurate and clean information. Or in your application, or somebody can upload a file to blob storage, and you can transform the data, import it into CSV or to another application, or apply it with Power BI, for example. So we have a lot of scenarios where a trigger, like a photo taken or webhook that's called, can either go and upload. So your function can programmatically then store that information and scale down some of the information. That brings me to my first demo. So I'm just going to escape out of my PowerPoint and go to my Azure environment. So when looking at functions, so I'm going to click on my functions. In my app, I've already added it through all services, just by, adding it to my favorites. And you can see that on the functions, I have app services. So a function is basically an app service or a type of app service. So I can either see it through my function app, where it will only list my app services that are functions, or my app services that will list all my app services and also list my functions. But I'm going to go to function app, then I don't see my other app services, which are just web applications or web apps. So this is really just an app service that's hosting my function. So I've got two functions over here. And there's a number of ways you can go and create these functions through Azure Portal. You have CLI, PowerShell, programmatically through Visual Studio, and ARM templates. And if I just go quickly show you, it's pretty much basically the same. I'm clicking on add. I select my subscription, my resource group. I give my function application a name. Yeah, I'm just going to call it test app function 1. And I can publish this as my code. I can also publish a container. And these are the different runtime stacks that I can go and select. So my function can be PowerShell script, Java, Python, Node.js, .NET Core. And then I can also select specific versions, based on the requirement. I'm just going to select .NET Core, and my region is West Europe, because that's the closest region. Next, I link it to a storage account. Depending on the underlying infrastructure, I can also have a specific, once again, it depends on my application and the underlying infrastructure that might be required. And then how do I plan on having it priced? So you have different options. So you have consumption-based, which is really pure services, on-demand scale. It's hosted by Azure. Premium, if I need more advanced features, more custom underlying infrastructure, maybe it's a function that is going to be running almost continuously. So I might want to make sure that the infrastructure to host my application or function is always available, so that I'll then take premium. So the third option is app service plan. Now, with function app being underlying app service or of the type function, I can have an underlying app service plan that runs my other hosted apps, and they can utilize the same app service plan depending on the infrastructure that I might already be paying for or have available within my subscription. So with monitoring, I can enable monitoring. I'm just going to remove monitoring just to speed it up that much quicker. And then by clicking create, it will go and create my function for me. So it's basically just my function shell. Now I can go and add my code to that. While that's busy finishing up, I just want to take you to my one that I have already created. So depending on my function code, I need to input my function and specify the trigger for that function. So I can create a new function based off a template. For example, I can say based on a HTTP trigger, and then specify the type of authorization level. So I'm just going to go back to my function called HTTP trigger 1 that's already triggered by a HTTP webhook that's been enabled. It's also been enabled. So I can go look at my code. So this is basically my HTTP trigger code. I specify .NET, and it's really just my programmatic steps. So it's got a string defined as name, discard, string defined as name. That's going to query, and it's basically just a HTTP trigger or webhook that will be triggered, and if I don't input the name that it requires, it will tell me that I need to pass the name. If I input my trigger with the name, it will just display that, and that is, as you can see, my response message. So it's basically an input and a response. So if I were to test or run this, I've already add it in and just go do that. So I haven't given the trigger information, but it has run, and it's telling me, pass a name in the query for a personalized response. So if I update my webhook and trigger it with a name equals, and I'm just going to put in Kazim's name. So by pressing enter, my response is hello, the personal name that I inputted, and then my HTTP trigger function. Now this is kind of like a basic trigger response function. Now obviously the function, you can, depending on the type of trigger, so you can have multiple or different kinds of functions of different triggers. For example, timer, queue storage, service bus, function that will run if you create a new blob, etc., or event. So all the different triggers that's available. And, so that's a simple version of a function, and your function is literally just your code that's being hosted somewhere in the platform, and then whenever it's triggered, it runs. Now I have a different function application that I kind of have been using for some while now, because it contains a lot of different elements within Azure, and it's basically it's a web application with different functions. So my application is really just a static web page that instead of running it as an app service, I've hosted it on a storage account, because one of the features of storage accounts is that it can also be used as a host of a static web page, because Azure Storage can also be accessed through HTTP, HTTPS URL, for example. And I've got these 3 functions. So my application, I allow the end user to get an image, upload the image to my storage, resize that within my application on my web page, and also write that data to a Cosmos database. So one of the functions is get images. So go into my code. It's really just my code that's being executed. Same thing within my other function, uploading the URL, and the triggers are HTTP triggers and resizing my blob data. So just to have a look at that application in effect, let's just go and my resource group. Quite often I forget what the website is called, and this is one of the things that everybody can pretty much also try wherever you are in the world, because it runs on Azure, so automatically it's got that international scale and availability. So if you can see this URL, https /stg ADH serverless app.z6.web.core.windows.net, and it basically allows you to click on upload and upload a file, choose the file. I'm just going to choose one and upload that. So it's basically just going to upload my file over there. And the programmatic things, or the trigger, is whenever I click on upload. So that's my functions that's being triggered. And the nice thing is about, hosting this web application or static web site on storage is cheaper than hosting it on an app service. So there's no underlying app service plan, virtual machine infrastructure that needs to run. It's running straight off storage, and my programmatic part of the application is really just the functions that I've defined, and I'm utilizing a Cosmos database to store information on my my data. So quick, simple, easy, no infrastructure that's constantly running. For example, I don't have a virtual machine where my app is constantly running. It's only really just billing once somebody clicks on upload a file and upload that data. So I hope that is a good example of a serverless application. And just to go back to my presentation. So that was my demo. Now, traditionally, this demo scenario would have had a server part of the application, so a virtual machine where my application is running, and obviously my database where I'm storing my data. And the thing is, I'd have to be paying constantly for both of those options. So my virtual machine application, if I had it as a VM, so I've converted that into storage, which is a storage account, blob storage, hosted as a static website, Cosmos database, and my function. So cloud natively, my architecture looks like this. So I have web static content that uploads images to blob storage. I can also attach that to Azure AD, so that somebody needs to log in with Azure AD or a Microsoft account. And then these are my different functions that I have resizing my image so that you guys could see that it takes whatever image that I uploaded and resize it into a small bitmap. And then you have Azure Cosmos DB and other options that I can also attach to that application. For example, computer vision, where Azure could tell me, hey, that's an owl or a dog or a cat, etc. So that was my demo that you guys just saw. So functions are great when it's really simple, easy, stateless. And there were some traditional scenarios where it's difficult to refactor into serverless functions, but you can either host it as a container or, for example, you need a function that's going to be running longer than allowed for the platform. So even through, if you have app service or premium plans, so they can be an option. So premium plans, if you have to run it constantly, and for consumption plans, you don't really want to have. So in a way, you'd also need to know how frequently will your function be triggered to choose the right scenario or platform for your function. So quite often, some easy scenarios, requesting a job, request job, that function that puts it to a queue, and then the function is triggered from the events that is in a queue, or another function that will just split up and get the status from that container service. So with automation is one of the best scenarios for functions, and as you can have a function based off PowerShell as the language platform, so you could use PowerShell in functions for Azure automation within your infrastructure, for example, if you'd like to do that. And some of the common event-based automation scenarios, if you need to do some remediation, for example, an alert went off, you want to have custom monitoring provided of resource events, or things like Office 365, Azure AD management tasks. A new user gets input and that is triggered, and the function, for example, of all the custom things that you have within your organization for that end user, for example, kick off new email, requests for new hardware, integrating with things like Autopilot for Intune, that sort of stuff, and even ITSM, integrated service management integration. So great for stateless, but sometimes you have what we call durable functions for long-running workflows, where it's more stateful workflows, or workflows that's in code and not available through Designer. And depending on whether it's synchronous or asynchronous, you might want to have checkpoints or pauses or halts, and or orchestration happening. So some of the durable function patterns is where you might have function writing to a database and another function that's only doing specifically smaller bits of sequential or asynchronous calls, or you need to have multiple function on a specific triggers or data in a kind of fan out, fan in with ongoing monitoring, or where you might need some sort of human intervention within your programmatic process. So you might have a request approval, and then, the function only starts to kick in where manual intervention has happened, so it's not really fully automatic. So that pretty much covers functions. Looking at integration side, integration is great with where we can go and create logic apps. And the nice thing with logic apps is that logic apps are basically integration workflows where you have different kinds of connectors and connectors with different services within Azure and also external services. So I first want to show you the demo. So I'm just going to go back to my Azure subscription and go to Logic Apps. So I already have a Logic App, two Logic Apps defined. So I'm just going to click on Add to create a new one. And once again, you have your subscription, specify your resource group. You give your Logic App a name. I'm just going to call it 1. And your location, you can also tie in your region or an integration service environment. So where you can tie it up to infrastructure that you already hosting on Azure, and you can just go and specify one if you have it. I'm just going to leave it on West Europe. I'm going to leave off analytics and tagging, and I'm just going to click on review and create. So I'm just calling it App 01 so that it's available in my subscription. And I want to go to complete. So you can see that it gets defined quite quickly because it's really just the creation of your Logic app, the name and the entity. So now you still have to go and build your Logic app. So one of the nice things when you create one, you have this nice information bar where you can start off with a video and learn about creating it. But it all starts with the trigger, right? Just like the function, my Logic apps will take in effect when it gets triggered. So based on the type of trigger, I can have a number of different triggers. So some of the nice options here is when maybe a file is created in my OneDrive, or a message is received in a service bus queue, or an HTTP request, or on timer. So I can even set this on a schedule. FTP file, email is received, or also tie in on social media. And that's one of the nice things with Logic apps. They have all these different connectors for different services. Some are Azure services and some are also social media services. For example, a company like H&M, for example, or any clothing manufacturing company or sales company can find out what people are saying on social media about their products and act, create a Logic apps that will look at social media, for example, search on their name or their products, and then act in on their data. Because quite often now in the new way of doing things, we're not just looking at the data that we have, but also what our clients think, what our partners think, and what general public thinks of our products and our things. And Logic apps is a great way by utilizing the designer to go and use it. I can also start a blank Logic apps or specific templates. So I'm just going to click on blank ones, and you can see that some of the recent ones that I used, some of the connectors. So if I click on all, you can see that there's quite a large number of connectors available within Azure Logic apps. So some of the built-in ones, the standard ones for Office, Twitter, Salesforce, etc. Enterprise integration connectors, for example, tied to SAP, MQ series, IBM services, and also custom connectors if I had any. So one of the connectors I can choose is things like, for example, an RSS feed. So when something is published on an RSS feed, I can place in the URL and have that checked every minute. So once I have my trigger, I can create a next step. So the next step, I can choose another connectors. For example, I can choose that somebody is notified that there's been an update. For example, I'm just going to exit this and take you, for the sake of time, to one of my previous logic apps that I've defined. So I'm just going to jump straight into the Logic App Designer. So my Logic App is defined through two connectors. So my trigger connector is when a feed item is published in an RSS feed, and my next step is send an email. So this Logic App looks at the CNN latest RSS feeds every minute, and it will just send an email, and it sends an email to my account based on the information that I've defined. And the nice thing is I really just select my connector, and whatever features and functionality and properties my connector has, I just have to specify the details. For example, I specify the feed and how frequently it needs to check. In my send an email, I specify the mail I need to send. So firstly, I sign in with that account, and I'm sending it to myself, the email address. My subject is my news item with the feed title, and then the body of my email that I've defined. And that's pretty much it. And when I click on run, for example, it's running in the background, so it will successfully check the trigger and publish my data. So obviously I need to go check in my email. So by going to my email, just miss something. Checking in my email, I can see that quite a number of these news items, if I click on the last one, is that a mail has come in. So that an item has a run, and it's got the news item of the feed, and as you can see, every minute that is basically gone and checked that feed and sent me whatever update has been happening. So this is one of the things. So by looking at different scenarios, you can basically be really creative. Think in terms of maybe in a business environment, you have either an employee or customer that's buying something through your web shop, and all that information is being written, backdated into the table. So you could see which client bought whatever product you had, and based on that data, you can then further have certain checks. Maybe the customer bought 10 items already. You know, if you have some sort of loyalty program, for example, like a lot of the companies have, like a loyalty program where they build points or they get free gifts. So you can have, with minimal code, all these connectors, and you basically just have to point and select the steps of the workflow within the connectors. So there's quite a lot of different connectors that you can go and utilize. So I'm just going to go back straight into my presentation again. So the nice thing with the Azure Logic Apps is that you have the integration and workflow in Azure through a visual designer. There's also the code view option where you can just send it in as in JSON format, and it allows you to connect applications, data, different services within Azure, and also orchestrate things like Azure Functions. So Logic App can also, one of the steps could be process a function, for example. So there's literally hundreds of connectors, you know, and these are growing quite phenomenally. If you look at things like within the Microsoft space for Office 365, things like SharePoint, Gmail services, you name it, a lot of third-party services available. So tons of connectors, and you basically just add them in your designer as a step, feed it with the information that it requires, and also where the output should be as the next step. So Logic Apps, pretty much, they connect everything, basically. And great for connecting resources also within Azure, for example, trigger functions, and kick off different workflows that either through the cloud or in a hybrid form. You know, things on premises that happens in the cloud and gets written back to your on-premises gateway. So that really just ended my serverless platform components. But before I continue, I'm sure you've seen a lot of this automation before, where you have like a workflow designer. You know, in Office 365, you also have Power Automate, like Power Apps, which is the ability to just quickly, with minimal or no code, and Logic Apps is a lot like that. And now I want to say thanks. That's pretty much all my content. Are there any questions or anything that anybody has at this point in time? Kazim.
Okay. Thank you very much for the powerful session, Adnan. Someone was trying to ask, he wants to be sure if serverless application is one that the server is not always, that the server does not always have to be on. It runs when needed. It runs when the function is triggered. It just wants to be sure.
Yes, that's correct, Kazim. You have consumption-based. So it's basically you have your function defined, and it's just sitting there. So there's no permanent, if you take consumption plan, there's no permanent infrastructure that your function sits on. It's just sitting there waiting, and when it needs to run, Azure provides or facilitates the runtime environment for it to run in.
Okay, so that would mean that it is more cheaper when we compare it to the likes of doing PaaS, for instance, you know, having a web application running on Azure.
That's exactly why it's cheaper, Kazim. That's exactly why it's cheaper. And that's why in some scenarios, it does have a benefit to run it as a consumption plan. But I've seen clients where it's a pretty complicated environment, and whatever they need to have happen needs to run a bit more. And in some cases, it makes more sense to have, based on its use, if you're going to run it as a premium plan or on as an app service plan. So it's basically just the underlying platform. If you have something already available and your function is going to be running quite a lot, so it all depends on what the function needs to do and how frequently it needs to run.
Okay. So that's the only question that I have in the chat box now. So I said, if there's any question from anyone else, so you can unmute your mic and speak now, if you would like.
Or they can just connect with me on LinkedIn or social media. Follow me on Twitter @MicroSpecialist. Send me a DM, and I may not always reply immediately, but I always reply. So.
Yeah. Okay, so thank you once again, Adnan, for sharing your time and your knowledge with us today again. So what I'm going to quickly do now is to share, the LASU CBT YouTube channel on the chat box. So I would like you to please subscribe to the channel. So whenever we have any video up on the channel, at least you can get notification of those videos. So you can always go there and do a replay of some of the previous episodes that we've had in the past. So, and I will just quickly mention something. We're trying to work on an Azure masterclass with Adnan. So hopefully soon, once we have the date set, so we're going to be letting you in on it. So thank you everyone for joining the webinar today. And let's do this again next month. So we do this twice every month. The first half of the month is on Azure, is on Power Platform, and towards the tail end of the month we have Azure, by Adnan. And maybe next week or maybe next month, I beg your pardon, Adnan, we can have something together, right?
Definitely,
Well, we'll try.
definitely.
Yeah.
Also, if there's anything specific that one of the viewers would like to see discussed or spoken about, or maybe a question on something else that's Azure, let Kazim know, and we can facilitate a session around that information. So just
Okay.
let us know. Everything in a lot of the masterclasses that I have held, it can basically bring you from an Azure Zero to an Azure Hero. And we pretty much cover everything that's required for an Azure administrator level. So if you have affinity to, become an Azure administrator or learn something more in depth in Azure in a class, you can just stay tuned.
Yeah. So you've heard it from myself and Adnan now. So let's do this again next month. So continue to keep safe and stay healthy. So from me, it's a bye-bye today. Adnan, thank you
Right.
very much.
Thank you, and bye-bye.
Yeah,
Stay
bye-bye.
safe, everybody. Bye-bye.
Bye.